Hi everyone, and thanks for joining for this short introduction to Teccarto Professional Map Data for Tableau Software. In this session, we have three workbooks. In the first, we'll show the built-in mapping functions in Tableau. In the second, what happens when you use external latitude and longitude data and the limitations of doing so. And in the third, the Teccarto data and how this restores all the built-in functions of Tableau to your own geography. So let's get started with the first workbook. This workbook contains the sample data that ships with Tableau. Notice that we have city and state information and that Tableau knows about these things. There's a little globe icon next to these items, which means that Tableau can generate latitude and longitude values for us. On the left-hand column, we have a filled map showing the states and sales is on colour. On the right-hand column, we have a circle or symbol map showing the cities with sales on size and profit is now on colour. And we can use the dual axis feature of Tableau to combine these two maps and show the state and the city information at the same time. All these built-in functions are available if Tableau knows your geography. Now we're going to use the second workbook. This contains geography that Tableau doesn't understand, and as we'll see, things get a little more awkward. Our first data source contains information about census tracts in California. As you can see, Tableau doesn't know about census tract. There's no globe icon. So if we want to generate filled maps for these, we need to tell Tableau about every point, how to join them up, and also provide our own latitude and longitude information. Once we have all these details, it's not too difficult to use the polygon mark type together with our own latitude and longitude details to generate a filled map. But we're showing approximately 8,000 census tracts through California here, and in order to draw the map, we're using almost 3 million marks. This gets complicated very quickly. Our second data source contains information about public schools in California for the same census tracts. We've got information about the individual schools, and again, we've got our own latitude and longitude data. We can use the circle mark type together with our own longitude and latitude data to generate a symbol map. Now, we want to join the two maps together, like we did for the sample data. Well, we can very easily blend summary data between the two data sources. In this case, we're showing the number of records for each census tract on colour. But if we want to show the individual schools, then we're out of luck. What we get is a single mark at the average of the region, and this mark represents multiple schools, as shown by the asterisk against school name. So using external geography with Tableau can be useful, but it certainly has its limitations, and we can't replicate the built-in functionality that Tableau provides. Now let's take a look at workbook 3. This contains the Teccarto geography that we've previously told Tableau about. In this case, we've got a single data table, which contains the same public school information as before. We've got individual school details, as well as the census tracts to which they belong. And notice that Tableau now knows about census tracts, and we've got a globe icon. We've also told Tableau about the detailed zip+4 codes. We've got no latitude and longitude in the file. We do have a set of measures, but we only have the generated latitude and longitude values provided by Tableau. So let's see what we can do with this data. To begin with, we want a filled map on census tract. And with Teccarto, this is a one-click operation from Show Me. Here we have our census tracts, and notice where we don't have any school information, there the census tract is not plotted. We're showing about 4,500 of the census tracts, and notice that we're no longer using nearly 3 million marks to plot the boundaries. Let's get a second column up on the map so that we can show the school information as well. On the right-hand column, we'll change the type to a circle plot, and we'll also switch out the census tract for the zip+4 codes. So if it wants to come out, we'll get the zip+4 codes. There we go, that's better. Okay, so we'll add the zip+4 codes, and we'll also add the individual school names onto detail, and we'll also get the individual unique school code so that we've got all the schools plotted. Notice that here we've got our all of our schools and all of our census tracts. We'll add the school type onto color, and we'll also add the enrolled total onto the size of the circles for the schools. Now that we've changed our circle map, let's go and to our boundary map, and let's add the families with own children, and let's use that as our background measure for the census tracts. Once we've done that, we can now use the dual axis function and combine and overlay the two sets of data. Notice that because the data is so detailed, the urban areas are very, very dense. So now that we've got this map, let's go ahead and make a duplicate and zoom into an area of Los Angeles. We'll use the standard rectangle tool to mark out an area to zoom, and we'll get it about right. And then we'll repeat the operation a second time to get it just the way that we want it. So carefully drag out an area that we want to see, and that's just about right just there. Okay. At this level, let's make a couple of adjustments. And for the circle marks for the schools, let's now add a border onto the collar so that it stands out against the background. And for the census tracts, let's change the existing black border for a white border to give us some additional contrast. Now we can see the detailed data against the census tracts, and we can highlight individual schools and see the data practically to city block level. At this stage, we can do anything else that we want to do with this map. So we can change the colors, for example, and let's, in this case, for the schools, let's look at the enrolled total on the size. So we're looking at the size of the schools. And then for the census tracts, let's look at the school population between 15 and 19 years. So now we're comparing the school population with the size of the schools. Let's quickly look at some filtering here as well. So we'll get a simple slider filter, and we can on enrolled total. So we can now look at the individual sizes of the schools, and we can use the filter to remove the smallest schools and just focus on the very largest schools, and are those schools where we've got the highest potential student population. So we can filter schools out, we can go back the other way, bring them back in again, and we can now look at the relationship between these two variables. At this stage, we have access to all the built-in functions of Tableau without limitation using the Teccarto geography. In summary then, we can see that the built-in functions of Tableau work brilliantly across all map types. When you bring your own latitude and longitude, then symbol and field maps get harder, and combined maps are just not possible. But with Teccarto data, the built-in functions of Tableau are once again seamlessly available across all map types. Teccarto data is available in any country. You can have multiple levels of detail in your geography. It works with Tableau Desktop, Server and Reader, and on Windows and the new Mac version. Teccarto is a partnership between FlyingBinary and All Map Data from Map Mechanics. To learn more, visit flyingbinary.com/Teccarto, and to purchase, visit allmapdata.com/Tableau. Thanks for joining us, and we'll see you next time.